which is isotonic. Which one needs more energy?
Ejection.
No, here. Because
Contraction.
you want to increase the pressure inside the left ventricle. It needs more energy. Isometric.
But the volume is constant.
You see, when the pressure reaches to a threshold and the inertia is actually added to it. You see, when you want to push a car, it needs more energy when it starts from the static state.
Yeah, at first.
But when it moves, then less energy is needed.
Yeah.
Am I right?
Yes.
So that would be the same situation. The pressure goes up and then the aortic valve is open. Here you need less energy. Let us give you another formula which is called Laplace. You see, this is the left ventricle. In isovolumetric contraction, the pressure inside the left ventricle will go up. See? We have two types of pressure here. The pressure inside the left ventricle wall, which is called tension. The pressure of blood inside the left ventricle, which is called the pressure. So, based on the Laplace formula, tension of the wall of the left ventricle or any spherical matter, any spherical volume, the tension in the wall of that spherical volume equals to pressure inside that volume times the radius over 2. Pressure, radius over 2. Tension equals pressure, radius. TPR, huh? You have learned what is TPR? Temperature, pressure, respiratory. No, in clinic. In clinic, TPR stands for temperature, pressure, and respiratory rate. So, based on Laplace law, the tension inside an spherical body matter equals to pressure inside it times radius. If you suppose that the left ventricle is a circle form, is in a spherical form, the tension inside the left ventricle equals the pressure inside it times its radius.
Yes.
Now, how many types of energy source do we have in our body? We have discussed it just in previous holidays, huh? Two types. In the presence of oxygen, in the absence of oxygen. Oxidative phosphorylation and glycolysis. You have carbohydrates, proteins, and lipids, fats.
So have these sources of energy?
Yes, foodstuffs are lipids, proteins, and carbohydrates. 70 up to 90% of the energy for the heart activity is coming from fat. it's better to say fatty acids. And the rest, 70 up to 90% of the total energy for the cardiac activity is coming from fatty acids. The rest, 10 up to 3% is coming from carbohydrates, lactate, and less from amino acids. We have two types of energy formation. One from oxidative phosphorylation in the presence of oxygen, which is actually carried out in mitochondria. In mitochondria. And the rest, we need oxygen for that. But in the absence of oxygen, which is called glycolysis, we do not need oxygen. In glycolysis, from glucose, 2 ATP is formed, just 2 ATP. But from oxidative phosphorylation, which is carried out in mitochondria, from each glucose, we can take how much? How many ATPs?
28.
380.
300.
80. Sorry, 308.
30.
308. 2 is used and 36 is left. 38. 38 is formed. 2 is used and 36 is left. From each glucose molecule, 36 ATP is taken in the presence of oxygen. So, the heart is very dependent to oxidative phosphorylation.
Heart.
The heart, we are talking about the heart, yes. Heart. So we need oxygen. And if we want to see how much work is performed, we can measure how much oxygen is used. Am I right? Because cardiac energy is dependent to oxidative phosphorylation. That is why when there is no oxygen, you will have myocardial infarction. Exactly. So if there is a method to measure the amount of oxygen that is used during cardiac work, then you can measure how much work is done. So there is an index, tension times time.
Has to equal what?
Tension times multiplied by time, which is called tension time index. This index gives you a rough estimation of the oxygen that is used, of the work that is performed. 50% of the total work of the heart is dedicated to isovolumetric contraction. Yeah, this is around 50%. This is not mentioned in guidelines.
Around 50%.
50%
of work.
of the total oxygen, of the total work, is dedicated to isovolumetric contraction.
So the amount of oxygen used is actually the energy.
Yes. Because the heart is very dependent to oxidative phosphorylation.
So work and the energy, that is oxygen, is related.
Exactly.
So can we take 5 minutes or 10 minutes break?
10 minutes break?
5 minutes.
5 minutes.